The beta version of GeoStudio 2019 Build 3D is now available. This quick start guide provides a short overview of the features and capabilities of our 3D modeling software. This video demonstrates how to create a three-dimensional model from an existing 2D analysis using the same project tree format and model workflow as two-dimensional GeoStudio models. We will set up our geometry in the new 3D editor, offering feature-based geometry design. The main features highlighted in this video are extrude, cut, and merge. We then demonstrate how to apply materials and boundary conditions to the three-dimensional domain, how to generate the 3D finite element mesh, and how to solve and view our results. Finally, a two-dimensional cross-section is generated from the 3D model to be used in a slope W stability analysis. When opening GeoStudio, you will notice that an additional drop-down menu is available on the Start page, allowing you to select the geometry dimension. After selecting a dimension, the corresponding products are highlighted. All products are available for two-dimensional modeling. Currently, SeepW is the only product available for 3D modeling. However, GeoStudio's three-dimensional analysis capabilities will increase over time. I will open the Analysis Quick Start Guide. In the Define Project window, we can see the seepage analyses are conducted on a two-dimensional domain. However, a GeoStudio project may include multiple geometries, including both two-dimensional and three-dimensional configurations. To add a 3D geometry to the project file, click on the top of the analysis tree, press the Add button, and select 3D Geometry. Seepage analyses can now be added to this geometry. You can see that the project tree navigation is the same as previous versions of GeoStudio. You will notice when clicking from the 2D geometry to the 3D geometry, the GeoStudio window looks slightly different. For 3D analyses, the main portion of the GeoStudio window is a read-only preview of the 3D domain. The preview window does not provide any editing capabilities, but we can zoom, pan, rotate, and select geometry items in order to view their properties. To conduct a 3D analysis, we will follow the same project workflow as for a 2D analysis. The workflow steps are: 1. Set up the model geometry. 2. Define the materials and boundary conditions and apply these to the domain. 3. Generate the finite element mesh throughout the domain. 4. Solve. And 5. View and interpret the results. Let us set up a 3D geometry based on the cross-section defined in the 2D seepage analysis. To import an analysis into our 3D analysis, we must launch the 3D editor under the Define menu. I will then click on the drop-down arrow beside the Import icon along the top toolbar and select Import Analysis. This feature is specifically named Analysis and not Geometry because importing a 2D GeoStudio analysis brings the geometry, materials, and boundary conditions into 3D. I can choose which of the two-dimensional seepage analyses I wish to import into 3D. The two-dimensional cross-section appears along the z=0 plane, which is called the front plane. I will right-click on Front Plane and select Normal to confirm this. In addition to the front plane, there are two other construction planes available in the Geometry Explorer: the top plane where y=0 and the right plane where x=0. These construction planes assist in drawing sketches in the 3D model space and represent local XY coordinate systems. The imported analysis is listed as a sketch item under the design history. Right-click on this item and select Edit to view and edit the cross-section. The imported cross-section was comprised of two regions, and thus there are two solids created in our 3D analysis. These solids are listed under Bodies in the Geometry Explorer. When this geometry item was imported, the 3D editor automatically extruded the cross-section by 1 meter in the Z dimension. If we want to consider a 100-meter long section, we can add a slice at a distance of 100 meters from the front. To remove the default slice at 1 meter, right-click and select Delete. I want to add a high permeability cylindrical drain halfway along the embankment geometry. To do so, I will right-click on Right Plane and select Sketch. This opens the Sketch tools on the x = 0 plane. The orthographic view setting is typically required in sketch mode to better visualize the sketching plane. I can also modify how solids are displayed in the 3D editor. I will draw a circle with a center at x = -50 and y = 16 and a radius of 1 meter. This circle is a 2D profile called Profile 1 in the design history. I can now create a 3-dimensional solid by extruding this circle. This 3D cylinder cuts through the embankment because the cylindrical solid comes after the embankment solid in the design history and therefore governs. To remove the portions of the cylinder outside of the embankment, we will use the explicit Boolean operations available in the 3D editor by selecting the Cut icon. After assigning the input bodies, I will select the 4th option from the 5 cut options available. If at some point while setting up an analysis geometry, we realize the initial profile was drawn incorrectly, we can go back to this profile and modify the sketch. When we do so, this change propagates through to features below it in the design history list. In this case, the extruded embankment solid changes accordingly, and the cylindrical drain cutting through the embankment also updates. Similarly, if we change the location of the drain on Profile 1, the cut solid updates accordingly. This is one of the key benefits of feature-based modeling. You can modify the geometry at any stage of construction, and all subsequent operations update accordingly. We can easily combine multiple solids to create one using the Merge functionality in the 3D editor. Select the Merge icon and click on the solids you wish to combine. To undo this action, we can right-click on the Merge item appearing in the Design History list and press Delete. As noted before, the materials and boundary conditions are automatically created on the 3-dimensional solids when a 2D GeoStudio analysis is imported. The foundation material is applied to the bottom solid as shown in the Properties window. Similarly, the solid representing the embankment has the embankment material applied to it. To change the material associated with the solid, simply use the drop-down box in the Properties window to select a different material. To define a new material, we must close the 3D editor and open the Define Materials dialog. Now when we relaunch the 3D editor, we can apply this new material to the solid representing the drain. We can view the applied boundary conditions by selecting a face in the 3D view and looking at the boundary information in the Properties window. To apply a new boundary condition, select a solid, face, line, or vertex and select the desired boundary condition from the corresponding drop-down menu in the Properties window. Now that the geometry, materials, and boundary conditions are defined, we will generate the finite element mesh throughout the domain by pressing the Generate Mesh icon. We could use the default mesh settings, but I will change the edge length to 4 meters. We can also specify the dominant mesh pattern to be tetrahedral or hexahedral. After clicking OK, the 3D editor automatically switches to Mesh View. A status bar appears in the tray during meshing. If it is taking an excessive amount of time, you can click the status bar to launch a Build 3D Task Manager, where you can stop the meshing task and modify the element size. To switch back to the geometry view, click the geometry item at the top of the window. We are ready to solve the analysis. The solve method is the same as previous versions of GeoStudio. I will close the 3D editor, select only the 3D analysis in the Solve Manager window, and press the Start button to begin solving. In the Results view, I can view parameter contours on the domain by selecting one of the many options from the first drop-down menu. The second drop-down menu provides a list of parameters viewed as vectors. To view results in the Draw Graph window, we now need to specify a location from the drop-down menu. Unlike a 2D analysis, the locations need to be defined prior to launching the Draw Graph window. There are currently no locations defined in this file. To do so, I must go back to the Define view, open the 3D editor, and switch to Mesh view. The location icon appears at the top of the window. When selected, we are prompted to enter a location name. In the Location Editor dialog, I will add a new entity, select Edge under Location Type, and click on the edge I wish to view results along. I can add multiple locations following this same method. I will go back to Results view and open the Draw Graph window. Now I can create graphs given the locations set in the 3D editor. I will now create a two-dimensional cross-section from the 3D seepage model to use in a slope W stability analysis. To do so, I will click on the front plane as it runs perpendicular to the length of the embankment and select the section icon. In the editor window, I will modify the offset value to 50 so the created section is in the center of the 3D embankment model. After pressing OK, I will expand the Geometry Sections list in the Geometry Explorer. I will right-click on the cross-section I just created and select Generate. In the main GeoStudio window, you will see that a new geometry feature, Section 1, is listed in the analysis tree. If I go to Define Project, I can now add a Slope W analysis to investigate the stability of the defined cross-section. This simple example demonstrates the Build 3D modeling features as well as the similarities between three-dimensional and two-dimensional modeling in GeoStudio. Build 3D may also be used to develop complex three-dimensional models. For example, this 3D seepage analysis was created by importing a geological cross-section from an AutoCAD file, and the extrude, sweep, cut, and merge features were used in the 3D editor to establish a section of an open pit. This analysis can now be used to assess seepage into the pit. Thank you for watching and enjoy using GeoStudio 2019 Build 3D.